Okay, so we've talked about solving these basic equations. And we've noticed that within these equations, the negatives come up a lot. So I just want to do a quick review to make sure we remember how to do them. My pen working here. So if I have 23 plus a negative 47. Now remember, when it's addition, we can use those vectors with the number line. Starting at 0, 23 is positive, so we go to the positive direction. The negative 47, is it the same direction or opposite? It's the opposite. Longer or shorter? Longer. It goes past. And remember, what this picture is telling us is that the answer is negative. Remember, we talked about magnitude. They go in different directions, so the magnitude of the result is the difference in their magnitudes. What's the difference between 23 and 47? Yeah, 24. So that answer is a negative 24. We might have a negative 56 plus 18. So again, starting at 0, which direction do we go? Negative 56. From there, the 18, same or different? Different direction, longer or shorter? Shorter. So that's telling us, again, our answer is negative. And the arrows go opposite directions. So it's the difference between 56 and 18, which is 38. So negative 38. Or we might have negative 17 plus a negative 41. So we go to draw that picture. We start at 0. Negative 17 goes left or negative. Negative 41, same or opposite? Same. So it doesn't matter if it's longer. It's the same direction, right? So that picture is telling us, again, negative, because we're on the negative side of 0. Both arrows go in the same direction, so what do you do with the magnitudes? We add them. 17 and 41 make 58, so it's a negative 58. So the addition was relatively simple. I said, I don't expect you to draw out number lines, but I do very much so in my head. I keep these pictures in mind when I am adding with integers. The trickier part was subtracting. And I'm going to start out with simply something like negative 28 minus 15. When we subtract with negatives, we use the fact that subtraction is adding the opposite. So this first number is the negative 28. That does not change. The operation here, the subtraction, always goes with the number that comes after it. It acts on the number coming, or acts with the number coming after it. So subtracting 15 becomes adding negative 15. The opposite of 15 is a negative 15. So here we've got negative 28 and negative 15. The answer is obviously negative. Do we add the magnitudes or subtract them? They both go in the same direction, so we add them. 28 and 15 make 43. So it's a negative 43. So that's the confusing part when we're dealing with negatives. When there's negatives involved, just because we're adding, just because it's addition doesn't mean we're going to add. You know, the negatives in here, we can end up subtracting if those vectors, if those arrows go in different directions. Just because they're both negative doesn't mean we're not going to add. If both arrows go in the same direction, we add the magnitudes. Subtraction, well, it can be all messed up. Here, even though we're subtracting, we ended up adding the magnitudes because both vectors ended up going in the same direction. We might have 37 minus a negative 28. What is that going to become?
Positive 28.
You got it. 37 plus a positive 28, or 37 plus 28. Now that's adding positives, so we don't have to worry about drawing out the vectors. We could. You got 37 and you got 28. That becomes 65. Good. Or we might have negative 42 minus a negative 53. That one's going to become?
Plus 53.
You got it. Negative 42 plus a positive 53. Now that it's addition, we can draw out our vectors. From 0, we go negative 42. 53, same or opposite? Opposite. Longer or shorter? Longer. So it goes past 0. Tells us we're going to end up on the positive side. And the vectors go opposite directions, which means it's the difference in the magnitudes. So I just take the larger magnitude minus the smaller one. 53 minus 42 is 11. So it's a positive 11. Any questions on adding or subtracting? You can see from these examples, though, how important it is to change it to adding the opposite. I'm trying to keep it as subtraction with the negatives in there. It can be extremely confusing. Multiplication. 18 times a negative 4. Well, the first thing we have to do, now obviously I'm assuming we're doing all these without a calculator right now because I realize you guys have that negative button on your calculator. Hopefully you've figured out how to use it. Most of your calculators, like for this one here, negative 42 minus a negative 53, most of you have a negative button. Now the big thing is you cannot use the subtraction key. If you use that for the negative, it's going to screw up your answer. You have a negative button, usually looks something like this one down here. So we have negative 42 minus a negative 53. And of course the calculator does correctly give us the positive 11. So I'm going to assume you guys can do that part. What I'm doing here is just the reasoning behind, so if you're caught without a calculator, you know what to do, or you can do that estimate to know what to expect out of your calculator. So here, 18 times negative 4. The first thing I want to answer is, do we expect this to be positive or negative? Negative. A positive times a negative is a negative. Whenever we're multiplying or dividing, if they're both the same, in other words, both positive or both negative, the result should be positive. If there's one of each when we're multiplying or dividing, then we expect it to be negative. So we expect this answer to be negative. So now it's just 18 times 4, which is 72. So a negative 72. Or we could have a negative 11 times a negative 8. Do we expect this answer to be positive or negative? Positive. A negative times a negative is a positive. 11 times 8? 88. Or we might have negative 20. So I want these parentheses around this. Times 7. Do we expect our answer to be positive or negative? Negative. A negative times a positive. We're multiplying one positive and one negative. We expect a negative. So 20 times 7? 140. You got it. Division? A negative 24 divided by 8. First of all, do we expect it to be positive or negative? Negative. Again, one of each. One positive and one negative. We expect it to be negative. 24 divided by 8? 3. So it's a negative 3. Good. If we have a 32 divided by a negative 4. Positive or negative? Negative. A positive divided by a negative is going to be negative. What's 32 divided by 4? 8. So it's a negative 8. And finally, negative 18 divided by a negative 3. Positive or negative? Positive. A negative divided by a negative is a positive. 18 divided by 3? Is 6. It's a positive 6. So again, when we're multiplying or dividing, if we have both negative or obviously both positive, the result's going to be positive. If there's one of each, one negative and one positive, the result is negative. Now be careful. That is only multiplying and dividing. That does not apply for addition and subtraction. Addition and subtraction, as we saw up here, it depends on which one's bigger or smaller and all that. So addition and subtraction, it goes off of those vectors. And technically I should say just for addition, because when it comes to integers, we don't subtract. We change it to addition. Okay, so now with that behind us, we're going to start out now doing what I think is the single most difficult process in math. As I said, last class when we translated some simple phrases into symbols, we're going to take the next step, a little bit more complex of a phrase, and put it into symbols so that we can solve an equation. Now, of course, the next step after that is taking a word problem or a situation and figuring out how to put it into symbols. And we will look at that a little bit today as well. But that's something we're going to come back to over and over again throughout the summer, is word problems. So anyway, we're going to start out today with a sentence like 6 times a number is 48. So this is very similar to what we were doing on Tuesday. I'm translating the phrases. But there's an extra little piece here, and the spot that separates this extra piece is right here. The word is. On Tuesday, we had no verbs in our phrases here. We just had things like 6 times a number, or 8 times the number increased by 4, or things like that. There was no verb, nothing linking. It was just a statement. When we're looking at these, the verb is a verb. It's a being verb, so it's not an action verb, but it is a verb. That separates the two parts of our equation. So on before the is, we have 6 times a number. How do we express 6 times a number? We'll just use x for all of our missing numbers for today. 6 times a number is?
48.
Perfect. 6 times x, or just 6x. And yes, the is implies the equal sign, 48. How would I solve that equation?
Divide by 6.
Divide by 6. Very good. X has been multiplied by 6, so we divide by 6. That gives us x is 8. Now be careful in my math lab with these. Sometimes my math lab is just asking for the equation. Sometimes it does want you to take those next steps and solve and find x equals 8. So it will say so in the directions. Just make sure you're careful reading the directions. That you don't, if you're like me, I tend to get partway through the problem and assume I know what it's asking. Be very careful on these, because I've had a couple of these wrong going through them just because I got careless and assumed, oh, I'm finding the answer here and all it wanted was the equation, or the other way around. We might have the sum of a number and 9 equals 13. What word in this phrase is our verb? Sum is actually a noun. The sum is the result of an addition problem. Equals is our verb. Equals is implying an action of some sort. This must be equal to, or must equal. So on the left side here, the sum of a number and 9, how do we write that in symbols?
X plus 9.
X plus 9. And then, of course, equals is the equal sign, 13. And then, what would we do if we had to solve this for x?
Subtract 9.
Subtract 9. X equals 4. Seven is the difference of a number and 5. So here, our verb is. So to start this out, 7 is implies 7 equals what goes on the other side of our equation. X minus 5. Good. The difference of a number and 5 is x minus 5. Now, I get asked this all the time. In fact, I sometimes give this advice to students to do. The variable's on the right side, and some students get really hung up on that. They struggle with it. I get asked, can I switch this? And the answer is yes. You can exchange what's on one side of the equal sign with what's on the other. So I can make this x minus 5 equals 7. The key is you have to make sure you don't flip anything around. This side of the equal sign was x minus 5. That becomes the left side over here. Bless you. Make sure everything stays together. None of those pieces got lost. No extra pieces have been put in there. It's just x minus 5. Then, of course, the 7's on the other side. So some people just absolutely cannot solve it like this. They have to flip it like that to solve it. We're going to go ahead and keep it in this first form over here to solve it. What do I have to do to solve it there? Add the 5, yes. So 12 equals x. So 4 times a number increased by 7 gives you 19. I worded this one a little funny, a little different on purpose to see what you can pick up on. I'm just going to put the equal sign here. What comes before the equal sign?
4x plus 7.
Perfect. 4x plus 7. Here, the gives you is the verb. Well, gives is the verb. You is actually an adverb. 4 times a number increased by 7 is 4x plus 7. On the other side, the 19. What's our first step in solving? Subtract 7. So 4x equals 12, and then divide by 4. X equals 3. A lot of times, by the way, they'll put the phrase find x at the end of this. And that's how you know, if it says find x, that's how you definitely know you have to solve that equation to get a value for x. Okay, now, so in your notes, I'm going to have you do this one. $31 equals 7 more than 6 times a number. Find x, or find the number. So in your notes, I'm going to have you try that one. What's our equation we write out here? 31 equals 7 plus 6x or 6x plus 7, either one. In this form, I kept it in this form, though, partly because it's the first thing I heard one of you say. Also because it's a little bit different. You got to be careful in this form. To solve it, what do you have to do first? Subtract the 7. Good. We're so used to seeing it as 6x plus 7, you're getting to have what we add or subtract the last number. No, it's the one that's added or subtracted, which is the 7 is added. It's positive, so it's added. So we're going to subtract it. So we subtract 7, giving us 24 equals 6x. What's next? Divide by 6. So 4 equals x. So our missing number is 4. Now, with that example out there, I want to give you actually a generic equation without a phrase, just to see what you guys do with it. So looking at this equation, 19 minus 3x equals 7. And just yell out what your instinct is, because a good chance that your first instinct is going to be a little bit off, because this is a tricky question. But what is the first thing we have to do to solve this?
Subtract the 19.
Very good. We have to subtract the 19. Most people, when they look at this, they say, well, it's subtraction there, so we've got to add the 19. But what was done to this, what was done to our variable, or done to x, to build this equation, x was actually multiplied by a negative 3. The 19 is positive, so the 19 was added. A lot of people see that subtraction symbol there, and they think, well, subtraction is what is connecting the 19 to the x. It's not. That's really a negative 3. In fact, If we're being technical, we'd probably rewrite this as 19 plus a negative 3x equals 7. In that form, it's a lot more obvious what's really going on here. So yes, we subtract the 19. Another common mistake is people drop that negative. It is a negative 3x equals 7 minus 19 is?
Negative 12.
Negative 12. Now, I've done a lot so far today to avoid working with negatives. Here is one where it cannot be avoided. What do we do next?
Divide by negative 3.
Divide by negative 3. So we get x equals 4. Now, here's one where it is important to go back and double check. Let's put that 4 in for x. 19 minus 3 times 4 equals 7. Well, again, 3 times 4 is 12. And 19 minus 12 is 7. So we do get the same result. Double checking will help catch if you had any mistakes with the negatives. Okay, so enough with the generic word problems. Let's actually look at solving real problems. Now, when it comes to solving word problems, one common method is to have a problem where there is a formula. For example, we might have a formula of profit equals revenue minus cost. Now, there are all sorts of different words. Some people put it as selling price minus cost or whatever. But it's the same basic formula. So if I now give you the information that Stacy buys, bless you, Stacy buys shirts for $7 each and sells them for $13 each. In a week, where Stacy has $942 in profit, how many shirts were sold? Well, we have to fit this into this formula. So we have to express each of those items. First of all, profit. What do we know about profit in this problem? Yeah, $942, right? So we're given the $942. That's not necessarily their take home because they might have other expenses, but so $942. Revenue. Well, revenue is the sale price times the number sold. Do we know either of those pieces of information? The sale price, which is $13. We don't know the number sold. We're trying to find out how many were sold. So we're going to let the number sold be X. Now, cost is the next thing. Cost is equal to the item cost times the number purchased or bought. Now, we know the item cost is the $7 each. We don't know the number bought or purchased. We can't have a second variable here, though. But we assume the number bought is the same as the number sold, right? You had to buy them to sell them, and then once you sell them, you're going to buy back the same number. So we're going to subtract $7 each times X would be the number purchased or number bought. So now that we have an equation, what do we do to solve it?
Mine the 13x to the negative 7x.
Perfect. 13x and negative 7x makes 6x. Good. Then what?
Divide by 6.
We're going to divide by 6. So you're at 157 equals x. Any questions so far? Now, sometimes we'll have geometric formulas, like the perimeter of a rectangle. Perimeter of a rectangle, P, is equal to 2 times the length plus 2 times the width. A rectangle with a length of 24 inches has a perimeter of 82 inches. How long is the width? Now the wording here got awkward, and I kind of did it on purpose, because I'm asking how long is the width? You know, long here is not referring to the length, which is that your brain wants to make that connection. Well, long, I already was told the length is 24 inches. No, we're talking about how long is the width. Both the length and width are a certain number of inches long. It's just different phrases for it. So we're going to use our formula here. P equals 2L plus 2W. Do we know anything about P? It is 82. So we put P in for 82. 2 times the length. 2 times, do we know anything about the length?
24 inches.
It's 24. Plus 2 times the width. Do we know anything about the width? No, that's what we're trying to find, is how long is the width. Has to be something in here that's unknown, otherwise not much for us to do. So now here, we have to simplify before we can solve. We're asked to solve this for W, but before I solve it, what can I simplify? There we go, 2 times 24, which is 48. So that becomes 82 equals 48 plus 2W. What's next?
Subtract 48.
Subtract 48. So 34 equals 2W. And then
Divide by 2.
Divide by 2. 17 equals done. Now, I should have done it with the last one, and I didn't. But we're going to do it here. We need to double check to make sure the answer we found is what we're asked to find. W, of course, represented the width. We're asked to find how long is the width. So yes, that is what we are asked to find. The width equals 17, and technically I should have my units in there, which is inches. We might have a problem like Pete is 3 years older than Sam. The sum of their ages is 31. Find Pete's age. So we're adding their ages to get a total. There are basically 3 types of strategies when we're dealing with word problems. There's 2 items in each word problem that either add to get a total, subtract to get a difference, or they equal each other. Here we have 2 items that add to make a total. We have Pete's age plus Sam's age. Adds up to give us what? 31. Pete's age plus Sam's age equals 31. We can't have 2 variables here. We can't have Pete's age and Sam's age. So there has to be a relationship between them. Well, Pete is 3 years older than Sam. So I'm going to let X equal Sam's age. What does that make Pete's age?
3.
X plus 3. Because 3 years older. So now, when I go to solve this, before I solve, there's something I have to simplify. What is it?
The 2 x's.
The 2 x's. What does... If I combine x and x, I get 2x. Yeah, we think of that as 1x and 1x combines to make 2x. So this is 2x plus 3 equals 31. What's our next step?
Subtract the 3.
Subtract the 3. Good. So 2x equals 28. And then?
Divide by 2.
Divide by 2. X equals 14. So we got 14. We go on our happy way. We're all done, right? What did X equal? Now, I purposely was a little sloppy. I was sloppy in a couple areas here. Remember I said, once we solve our equation, we always have to go back and make sure that that answers the question we're being asked. When I wrote this out, I purposely did not clearly define what X was. I can tell what it is. X was Sam's age. Generally, I would write out the things I am looking for off to the side. I'm looking for Pete's age and Sam's age. Since Pete's age is defined off of Sam's age, I'll let Sam's age be X and Pete's age is X plus 3. By doing this here, I'm doing two things. One, I'm saving myself, or making it less likely at least, that I'm going to make a really bad mistake, a silly mistake. And I'm giving myself a formula to get to the right answer from what I have here. X represents Sam's age. Is that what I'm asked to find? No, I'm asked to find Pete's age. But knowing Sam's age, I can find Pete's age. Sam's age is 14, or X equals 14. How do I find Pete's age? Yeah, take Sam's age plus 3. 14 plus 3 is 17. Pete's age is 17. That is the result I'm looking for. So be very, very careful in these problems. Two things. One, just like I did here, define your variable. Don't just start writing equations with variables in them. Make sure you note somewhere, or make it clear to yourself and to anybody else looking at this problem later what the variable stands for. Second, when you are done, make sure you go back and check with the problem that the variable you solved for, the number that you found, actually answers the question being asked. Because I found those are two of the areas that cause a lot of mistakes. People don't write down what the variable stands for at the beginning, or they don't make sure they know clearly what that variable stands for. So they solve the equation, they just plug in what they get for the answer to the equation, but that wasn't the variable, that wasn't the item they were asked to find. So we might have something where an appliance repair technician charges $50 for a service call and an additional $3 per mile. How many miles away is a call that cost $98? So here we don't have a formula for this. No, we don't have a perimeter or a profit or whatever. We have to figure out some way to come up with this relationship ourselves. So remember, we have two things that add to make a total, two things that subtract to make a difference, or two things that are equal to each other. Here we have two things that add to make a total. We have and the words I use here are not important, it's what they stand for. You might look at this and choose different words. We might have the service call base charge, or however you want to call it, plus mileage, or however you want to talk about that, equals the total charge. For this situation, what do I know about the service call base charge? $50. How about the mileage charge?
$3
$3 per
per
mile.
mile.
And here's where our variable comes in. So we're going to let our variable equal the number of miles. I'm going to use M for miles. So 3M equals, what's our total?
98.
98. So then to solve this, we are going to minus 50. Good. So 3M equals 48. And then divide by 3. So M equals 16. So now again, we need to double check to see if that's what we're looking for. M stands for the miles. We're asked how many miles. So it looks like that is what we were asked to find. Any questions? Okay, well, with these word problems like this, the only way to really get good at them is to do them. I can give you tons of examples here to do, or to work along with me. It's only going to work if you start doing them yourselves. So I'm going to give you one here to try, and if that one goes well, we're going to give you the assignments for the day, and I'll give you some time to work on those assignments. So what we're going to look at here, a rectangle with perimeter of 56 has a width of 12. Find the length. So I'm going to give you guys a couple minutes to try that one, and we'll talk about it. So let's see how you did. Of course, the formula here, perimeter is equal to 2 times the length plus 2 times the width. Do we know P? 56. 2 times, do we know L?
No.
No, L is what we're looking for here. Find the length. Plus 2 times 12. Before we start to solve, we have to simplify what? 2 times 12. So 2 times 12 is 24. So we have 56 equals 2L plus 24. And then subtract the 24. 32 equals 2L, and then divide by 2. So 16 equals L. L is the length. Is that what we were asked to find? Yes, it is. So length equals 16. I didn't give any units in the problem, so there are no units to put on the answer. Now, like I said, 2 things. One, when we're working on these in class, I know they seem easier because I've done examples that kind of point you in the right direction as what needs to be done. So please don't be horribly frustrated if you go to do these and they're a little more difficult than they seem in class. Second, I don't expect you guys to be whizzes at doing these right now, especially word problems, but math in general, you only get better at it by doing it and struggling through it. And I mentioned it in the last classes, seeing patterns. There are patterns in these word problems. But like I said, the patterns I see might be different from the patterns you see. So the way to get good at it is to do enough so that you start to see a pattern. Everybody's mind works differently. So I'm going to give you guys the last 23 minutes here to get started on homework. There is a new quiz, by the way. Quiz 2, which is due tonight. at 11:59 p.m. And there's new homework. Homework 3, which will be due Monday at noon. Now, also a warning, just a heads up, because this is a summer class, things come up really quickly. So our test 1 or exam 1 is coming up next week, Tuesday. So we have the weekend here, good time to start reviewing what we've done all week to give yourself a little bit of preparation for that test. Because there will be new material Monday, and that new material will be on Tuesday's test. So there may not be a lot of time to go back and review between Monday and Tuesday. The way those tests usually work is I usually set aside the first hour and 40 minutes for the test. And then the last hour is lecture on new material. We do start new material because of the layout of the summer class. I mean, we have 3-hour classes. I can't take a whole class for the test. So the last hour is new material. If you need a private room, whether you have accommodations or if you just work better in a private room, that's something you need to get set up. So if on your location, you go to the library or wherever you have access to private rooms, and make sure you have one reserved for Tuesday. I'd recommend you reserve it from like 9 to 11. Or if you think you're going to need more time than that. My tests, I always allow you as much time as you need. So if you need to sit there for 5 hours on that test and do it, you can. The thing is, I want you to do it in one sitting. I don't want you to work on it for an hour and then go away for 2 hours and come back. The exception to that is when it gets to be like 10:30, 10:40 or so, if you're not done. Now, if the whole class is still working on it, I'll say, hey, let's keep working on this for another 20 minutes or so, and I'll shorten up my lecture or whatever. But generally to that 10:30 or 10:40, if you're not done, I'll have you go take a short break, set the test aside, we'll do our lecture, then you can finish up the test at the end of class or after class. If you want to come in early, if you think you're going to need more than 2 hours, I will have the tests out next Monday. I will send them out to your location. So whatever time your facility opens, most of the time you can pick up the tests from the ITV office. Generally, they'll actually have a folder at the front of the room. They'll put them in and just leave them in the front of the room for you when you come in. Or you should be able to get them from the library, either one in your location. Here, of course, you guys will just get them from me. But whatever time they're available. Some sites that's at 7:30, some sites that's at 8 o'clock. So let's just say at 8 o'clock, if you want to get started early, you can come into your site and get started early. Anybody have any questions on the test coming up? Okay, so like I said, that's just a heads up. The immediate things at hand are quiz 2, which is due tonight, and then homework 3, which is due for Monday. You guys have a great day. Like I said, I'll be here till about noon. The computer labs are open for you guys to use if you'd like.